So, hello everyone. Today's topic is linear inequalities. Linear inequalities. So, in this we will study linear inequalities in one and two variables. One variable and two variable. So, what are inequalities? What are inequalities? So, statement involving a sign such as statements involving a sign such as less than. This means less than, and this means greater than, and we have less than, equal to, less than, or equal to, and last we have greater than and equal to. For example, 30x is less than 200. So this is the type of inequality. It is not an equation. It is not a equation, because equation comes with a equal sign. Because equation comes with equal sign, and this is the inequality in one variable. Inequality in one variable. Second example, 40x plus 20y is less than equal to 120. So this sign means less than or equal to. It is a special type of inequality which contains two parts. So it is a special type of inequality that contains two parts. First is 40x plus 20y is less than 120, which is an inequality. Second is 40x plus 20y is equal to 120. So this is an equation. So this type of inequality consists of inequality and an equation. And this inequality is of two variables, x comma y. So this was about what are inequalities and how to write an inequality. So next is, what are the types of inequality? What are the types of inequality? So first is numeral inequality. Numeral inequality. So why is it called numeral? Because it does not contain any variable. It does not contain any variable, that is x, y, a, b, etc. So example of numeral inequality is 3 is less than 5, 7 is greater than 5, are numeral inequalities, etc. So there are only numbers in decimal form. Second is literal inequality. Literal inequality. Literal means it contains variable. It contains variable such as x, y, a, b, c. For example, x is less than 5, x plus y greater than 2, y is greater than 2, x is greater than equal to 3, y is less than equal to 4, etc. So all these inequalities are literal inequalities. So first is numeral inequality, second is literal inequality. So now we have third type of inequality, which is double inequality. Double inequality. For example, 3 is less than 5, less than 7. So it contains two inequality sign, two sign of inequality, two signs of inequality. Or we have 3 is less than equal to 5 and 5 is less than equal to 7, or 3 is less than equal to x is less than equal to 5. So it is mathematically incorrect statement. Incorrect inequality. Because 3 is not equal to 5 and 5 is not equal to 7. So these are type of double inequality. Fourth is strict inequality. Strict inequality. So any inequality which comes with a sign of less than or greater than is called strict inequality. So standard forms are ax plus b is less than 0 and ax plus b is greater than 0. So these are one variable linear inequality, one variable linear strict inequality. So why is it called linear? Because it contains only one power of x and one variable because it contains only one variable x. Second, ax plus by less than c and ax plus by greater than c. So this is two variable linear strict inequality. So we have two variables in this equation, x and y, and it is linear because x is having power of 1 and y is having power of 1. So next is ax square plus bx plus c is greater than 0. So this is quadratic strict inequality in one variable. Quadratic strict inequality in one variable. So we have one variable here, x, and it is called quadratic because x is having power of 2. So this is a type of a strict inequality. Next is slack inequality. So any inequality which comes with a less than equal to or greater than equal to sign is called slack inequality. So standard forms are ax plus b is less than equal to 0. It is one variable linear slack inequality. One variable linear slack inequality. Next is ax plus by less than equal to c, ax plus by greater than equal to c. So it is two variable linear slack inequality. And third is ax square plus bx plus c is less than equal to 0. It is quadratic one variable slack inequality. So these are the types of inequalities, that is numeral inequality, literal inequality, double inequality, and strict inequality, and slack inequality. So next is algebraic solution of linear inequality in one variable and their graphical representation. Algebraic solution of linear inequality in one variable and their graphical representation. For example, 30x is less than 200. So where x is positive integer, where x is positive integer, so therefore we will check for value of x for which 30x is less than 200. So we will check for values of x for which 30x is less than 200. So this is a strict inequality. So therefore at x equal to 0, 30x is equal to 0, which is less than 200. So it is correct. X equal to 1, 30x equal to 30 is less than 200. So it is correct. X equal to 2, 30x equal to 60, x equal to 3, 30x equal to 90, x equal to 4, 30x equal to 120, which is also correct, x equal to 5, 30x equal to 150, less than 200. So we are getting closer to 200. X equal to 6, 30x equal to 180, 200, x equal to 7, 30x, so 210 is less than 200, so it is not correct. So we will stop the iteration at x equal to 7. So we have a solution set from x to 0 to 6, where 30x is less than 200. So therefore solution set will be 0, 1, 2, 3, 4, 5 and 6, where x is positive integer. Therefore we can now define what is the solution of inequality. What is a solution of inequality? So any solution of an inequality is in one variable is a value of variable which makes it a true statement. So any solution of any inequality in one variable is a value of the variable which makes it a true statement, which makes it a true statement. However, the method we used is hit and trial method, which is not very efficient. But the method we used in 30x less than 200 was hit and trial method. Hit and trial method, which is not very efficient, and second, time consuming. So how to solve a linear inequality? How to solve linear inequality? So we will apply some rules that are applied while solving linear equations. We will apply some rules that are applied while solving linear inequalities. So rule number 1 is equal numbers may be added to both sides of an inequality. Equal numbers may be added or subtracted to both sides of an inequality. Both sides of an inequality. Rule number 2, both sides of an equation may be multiplied by or divided by same non-zero number. Both sides of an equation may be multiplied or divided by same non-zero number. Rule number 3. So rule number 1 and 2 are also valid for linear equations. But rule number 3 is only valid for linear inequalities. Only valid for linear inequality, which says that in case of inequality, the sign of inequality is reversed. The sign of inequality is reversed. That is, whenever we multiply or divide both side of an inequality, both side of an inequality by a negative number or a negative sign, by a negative number or negative sign. For example, 3 is greater than 2. So if we multiply both side by negative sign, both side by negative sign. So minus 3 is greater than minus 2. So here, because we have multiplied by negative sign, so this sign will reverse. So reverse this sign. So we can now say minus 3 is less than minus 2, which is mathematically true. Mathematically true statement. So this is how a negative sign if affect the inequality. We can also multiply the inequality by a negative number. Suppose 3 is greater than 2 and we multiply by negative 2. So we can say minus 2 into 3 is greater than minus 2 into 2. So minus 6 is greater than minus 4. So this is mathematically incorrect. Mathematically incorrect. So we reverse the sign. So we reverse the sign. Reverse the sign. Therefore, now we have minus 6 less than minus 4, which is mathematically true statement. Mathematically true statement. So coming back to our previous example, how to solve an inequality without hit and trial method. So let's say take an example, 30x is less than 200, where x is an integer. So by following the rules of inequality, we divide the both side by 30, divide both side by 30 by 30. So 30x by 30 less than 200 by 30. So this implies x is less than 6.67. So because x is an integer, because x is a integer, positive integer, therefore x is equal to 0, 1, 2, 3, 4, 5 and 6. So this is a solution set. So this is how we solve an inequality by using rules of inequality. Second example, 5x minus 3 less than 3x plus 1. So using rule of inequality, we subtract 3x from both sides, subtract 3x from both sides. So 5x minus 3 minus 3x is less than 3x plus 1 minus 3x. So this will cancel out and this will reduce to 2x minus 3 less than 1. Again, now add positive 3 to both sides. Therefore 2x minus 3 plus 3 is less than 1 plus 3. So 2x is less than 4. So again apply the rule of division, divide both sides by 2. So 2x by 2 is less than 4 by 2. So x is less than 2. So our solution set will be minus infinite to 2, where x is a real number. So if it is not mentioned that what is x, so we take x as a real number. So next is representation of inequality on number line. Representation of inequality on a number line. For example, 7x plus 3 is less than 5x plus 9. So by using rule of subtraction, we get 7x minus 5x plus 3 less than 5x plus 9 minus 5x. So this will reduce to 2x plus 3 and 9. Then subtract 3 from both sides, plus 3 minus 3 and 9 minus 3. So this will 2x less than 6. Divide by 2 both sides, 2x by 2 less than 6 by 2. So we get x is less than 3. So our solution set will be x belongs to minus infinite to 3. So now we construct the number line. So this is a number line. So x is less than 3. So this is 3 and this is minus infinity and this will, so these are all the points which are included in the solution set. So this is called a whole, which means 3 is not included in the solution set. Next is 3x minus 4 divided by 2 is greater than equal to x plus 1 by 4 minus 1. So by applying rules of inequality, we get x is greater than 1. So again we plot a number line. So this is negative x-axis and this is positive x-axis. So this is 1 and this is a solution set of all the values greater than equal to 1. So x belongs to 1 comma infinity. So this is called a solid, which means 1 is included in a solution set. Next is graphical representation, graphical solution of linear inequality in two variables. Graphical solution of linear inequality in two variables. So like before, here we take two lines perpendicular to each other. Like before, here we take two lines perpendicular to each other. Two lines perpendicular to each other. So this is a graph. So this is y-axis and this is x-axis. So here we plot the points on two lines perpendicular to each other. Perpendicular to each other. So what next is, what is a half plane? What is a half plane? So it is also known as Cartesian plane. Cartesian plane or xy plane. XY plane. So now what is a half plane? So line which divides the Cartesian plane into two parts. Line which divides the Cartesian plane into two parts, and each part is known as half plane, and each part is known as half plane. So this is the definition of half plane. So we have two types of line, two types of line which creates a half plane. One is vertical line and second is non-vertical line. So this is how we represent graphically. First is vertical line. So this will so this is a Cartesian system, and this is and so this is a Cartesian system, and vertical line will intersect x-axis at one point. So vertical line intersect x-axis. So this is x-axis and this is y-axis, and it will split the uh, this split the xy plane into two parts, which is left half and right half. And we have non-vertical line, so it will split the plane into upper half or lower half, and the region of left half and right half, or upper half and lower half, depends on the value of x and y. So next we have three possibilities three possibilities in case of non-vertical line. In case of non-vertical line, first is ax plus by equal to c. Second, ax plus by is greater than c. Third, ax plus by are less than c. So let's plot a Cartesian system. So this is a Cartesian system, and this is a line which is ax plus by equal to c, and this is y-axis and this is x-axis. So step 1 is we have to find which, so this is first region and this is second region, so we have to find which region is upper half and which region is lower half. So we will substitute x comma y equal to 0 comma 0 in any equation ax plus by less than c, or ax plus by greater than c. So if we substitute x comma y equal to 0 comma 0 in equation 1, therefore we get 0 is less than c, so which is true statement. Therefore we can say region 1 is the lower half, and if we put x comma y equal to 0 comma 0 in equation 2, then we get 0 is greater than c, so this is false statement. So which implies 0 comma 0 lies in lower half plane, lower half plane. So now we can say, this is how we find which is lower plane and which is upper plane. So this is our plot. We can say this is lower half, and this is upper half. As we can see, 0 comma 0 lies below the is less than c, ax plus by equal to c. So this is lower half and this is upper half. So next we have to prove that points any point in the half plane 2 in the half plane in the half plane 2 satisfies the equation ax plus by greater than c. Any point in the half plane 2, or we can say upper half plane satisfy ax plus by greater than c. So let's make a Cartesian system. So this is a line, and make a vertical line that intersect the blue line and the x-axis. So we have, so this is x-axis, this is y-axis, and this is ax plus by. It is a graph of line of equation ax plus by equal to c. So this line intersect at 2 points, this, and let this point be alpha comma 0 and this point be alpha comma beta, and take any point. Suppose this is a point, we can call it alpha comma gamma. So we have to show that any point in the upper half, this is upper half, satisfy upper half. So any point alpha comma gamma satisfy ax plus by greater than c. So in this case ax plus by greater than c, we have two cases, b is greater than 0 and b is less than 0. So in this, b is greater than 0. So now put alpha comma beta in equation 1, that is ax plus by equal to c. So a alpha plus b beta b equal to c. So this is a equation, and since it is clear from the graph gamma is greater than beta, So by applying the rules of linear inequality, we multiply both side by b, and add a alpha to both sides. So a alpha plus b gamma is greater than b beta plus a alpha. And from equation A, this is equal to C. So we can say A alpha plus B gamma is greater than C. So alpha comma gamma satisfy the linear inequality ax plus by greater than C. Therefore, any point in the upper half or half plane to satisfy ax plus by greater than C. So likewise we can prove for a lower half. So this is what is half plane and how to represent upper half and lower half in the Cartesian plane. Next we have a note. So the region containing all the solution of an inequality is called the solution region. So before finding the solution of any inequality, there are some rules. So the region containing all the solutions of an inequality is called the solution region. Is called the solution region. Second, in order to identify the half plane represented by an inequality, it is just sufficient to take any point a comma b and check whether it satisfies the inequality or not. In order to identify the half plane represented by an inequality, it is just sufficient. It is just sufficient to take any point a comma b and check whether it satisfies the inequality or not, whether it satisfy the inequality or not. So if it satisfies, then inequality represents the half plane and shade the region which contains the point. So if it satisfies, then the inequality represent the half plane and shade the region which contain the point. So there is a general method. There is a general method whether the point lies in upper half or lower half. That is, substitute, put x equal to 0 and y equal to 0 in the linear inequality, in the linear inequality, and if it comes to be a true mathematical statement, if it comes to be true, then we designate the half plane as upper half and lower half. Then we designate the plane as upper half or lower half. So now, for example, ax plus by less than c. So put x equal to 0 and y equal to 0. So we get 0 is less than c. Therefore, 0 lies in lower half. And if ax plus by greater than c, then at x equal to 0 and y equal to 0, 0 is greater than c, which is wrong statement. So therefore, 0 lies in lower half. Next is third point, if an inequality is of the type, if an inequality is of the type ax plus by greater than equal to c, or ax plus by less than equal to c, then points on the line points on the line ax plus by equal to c are also included in the solution region, are also included in the solution region. That is, dark line is drawn on the solution region, is drawn on solution region. Next point is, if ax plus by greater than c or ax plus by less than c, then the points on the line are not included in the solution region, and the points on the line ax plus by equal to c are not included in the solution region. So we draw broken line or dotted line in the solution region. So let's take an example. 40x plus 20y is less than equal to 120. So this is a inequality, linear inequality in two variable. So step 1 is check 0 comma 0 lies in lower plane or upper plane. Check 0 comma 0 lies in lower plane or upper plane. Therefore 0 plus 0 is less than 120. So 0 is less than 120. Therefore 0 comma 0 lies in lower half plane. Step 2, put x equal to 0 to find the solution set of y. To find the solution set of y. So we get 20y is less than 120. So y is less than equal to 6. So y belongs to 1, 0, 1, 2, 3, 4, 5 and 6. So this is how we plot. This is y-axis and this is origin. So this is 1, 2, 3, 4, 5, 6. So this is the solution set of y. Step Step 3, put y equal to 0 to get the solution set of x. To get the solution set of x. So we get 40x is less than equal to 120, which implies x is less than equal to 3. So x belongs to 0, 1, 2 and 3. So this is x-axis and this is 0, 1, 2 and 3. So now combine the two plots. So now combining two plots, combine two plots, we get so this is y-axis and this is x-axis. So we have x 1, 2, 3, 1, 2, 3 and this is 0 and y have 1, 2, 3, 4, 5 and 6. So here 3 and 6 are endpoints. 3 and 6 are endpoints. So 3 and 6. So step 5, join the endpoints. So this is how the graph will look like. These are endpoints. So this is equal to 40x plus 20y equal to 120, and we know that 0 comma 0 lies in lower plane. So this is a lower plane, and this is a upper plane, and this is 40x plus 20 greater than 120, and this is 40x plus 20 less than 120. So our solution region will be, because we are restricted to only integers, therefore solution set will be bounded by a, b, c. So this is a solution region because x is a positive integer. If x is a real number, if x is a real number, then whole lower plane, then whole lower plane will be a solution set. So next is 3x minus 6 greater than equal to 0. So we get, after applying the rule of inequality, x is greater than equal to 2. So step 1, put x equal to 0. We get minus 6 greater than equal to 0. So this is a wrong statement. So this is how the graph will look like. This is x equal to 2. This is x equal to 2. And therefore 0 lies in left hand plane. And this region is right hand plane. And because we have a sign of inequality, greater than equal to, greater than equal to, therefore a solution set will include x equal to 2 as well. A solution set will include x equal to 2 as well. Therefore this is a solution set. It is represented by a dark red line, and this represent x is greater than 2. So this represent x is greater than 2, and this represent x equal to 2. Therefore this implies x is greater than equal to 2. So this is a solution region. So next is solution of system of linear inequalities in two variables. Solution of system of linear inequalities in two variables. So let's say x plus y, we have two equations, x plus y greater than equal to 5, and second equation x minus y less than 3. So we plot Cartesian system for both the equations x plus y greater than equal to 5 and x minus y less than equal to 3. So for both the equations we apply the same procedure. First is step 1, substitute x equal to 0 and y equal to 0. So we get 0 is greater than equal to 5. So this is mathematically wrong statement. Similarly, if you put x equal to 0 and y equal to 0 in second equation, we get 0 is less than 3. So this is mathematically right statement. This is correct statement. So from here we can deduce that 0 lies in 0 lie in lower half plane in first equation. Similarly, 0 lies in lower half plane in second equation. So the plot of first equation will look like this. So this is a Cartesian system. This is x, this is y. So this is x comma y. X plus y equal to 5. And this is point 5 comma 0. And this is 0 comma 5. So we can see 0 lies in lower half plane. 0. This is lower half. And this is upper half. And our solution set will be in the upper half region, including the points on the line. Second, if we plot a Cartesian system for second equation, we get, since 0 lies in lower half, so this region will be lower half and this region will be upper half. So this is 0 comma minus 3 and this is 3 comma 0. So now if we combine two graphs, if we combine two graphs, two plots, we get the common region. So we have plotted the two graphs. So this is graph 1, which is x plus y equal to 5, and this is x minus y equal to 3. So in first equation we have this region is a solution set, and in second equation this region is a solution set. So our common region is this region. This is a region of common. So this is a common region including some points on x plus y equal to 5 and some points on x minus y equal to 3. So this is a solution set. So we can therefore double shaded region double shaded region common to the above two shaded region, that is double shaded region is the common region to the above two shaded region, that is the required solution region, that is the required solution region of the given system of inequality. So this was about linear inequalities and how to graph linear inequalities on a Cartesian plane and how to find a solution set. So thank you.